Hello all, thanks for being here. I'm Abhirami, Senior DevOps Engineer at Amsys. Here, I'm responsible for automating and supporting CI/CD in product development. Now, getting into the topic of my talk, it is about applying blockchain for digital identity management. Before moving into this, I would like to give a little introduction about my company. So, about Amsys. So Amsys is a reliable partner for product engineering services and digital transformation partner for independent software vendor as well as enterprises. Our offices are located at USA, India, and Vietnam, and our strength is 1,000 plus, and we are at growing. So we are the top fastest growing storage companies for 2 consecutive years. And to name few, our clients include Number Storage, Eurotech, NetApp, and EDN. Amsys also got many awards, and recently in 2021, we have received a DevOps India Summit Award 2021, American Business Award on Bronze Steve Winner Award, and People Choice Award, as well as we are on the top 100 list of global outsourcing. So coming to the agenda, first we will go through what a digital identity is and what are the issues we are facing in current identity management system. Then we will go through the blockchain adoption trend and technology as a solution for this issue. And we will look how this blockchain technology works and how exactly it helps in digital identity. Then we will look a use case of blockchain, and also we will have a comparison on checking a legacy as well as blockchain based onboarding process. Then we will go through the current blockchain related project that exists now. So coming to identity, it is one of the basic rights of any human being. So identity assets include a first and last name, the birth date, your age, gender, etc. In reality, every human needs to have an identity in order to work in our social environment. So in general, ID assets are recorded in physical ID document. Now, when talking about digital identity, it is an available online information about these ID assets that we are referring here, which means individual identity is represented through digital is called digital identity. So this is what a digital identity. Then we will discuss about what are the issues in current identity management system and how a blockchain can help for bringing into a decentralized identity and also the use cases. So let us go through one by one of the typical identity management system. So the first issue we have here is bad password combination, because many application has password based login authentication. In reality, we would be having expiration date, and also it will ask us to set a new password. So it becomes harder for the user to keep track of all the new password. As a result, password fatigue happen, and same password has been used for multiple accounts, or else we would be using the same previous old password, which increases the security risk also. And also, apart from that, we started using a generic passwords, which helps the hackers to steal our information very easy as we set our passwords like welcome or welcome123, etc. The second thing is failure due to manual provisioning and deprovisioning. So all the provision process handled by the department level only. So there is possible for getting a manual error. Similarly, while deprovisioning also happens by a departmental level, and there is possible for a manual error, where an employee he may slip away with access to the central server itself. So no regulation for access restriction. So we should be knowing who has access to what type of data and application and from which devices they are using this. So the issue here is it is valuable as a centralized system which lacks regulation and people we are suffering greatly. The second thing is the low security for identities in device and browser. So now everything is on internet and we all use browsers and devices, which means there is too many access point to one application. For example, to log into any application from any device, we are setting a multiple risk points. The next thing is application not being up to date. So no application is perfect. So we are having bugs or loopholes. So we need to update the application whenever there's a security patches or given by the developers. And the next thing is multiple administrative models for multiple application creates inconsistency. Again, enterprise company, they can have multiple app. If all app run on a different admin model, it is harder to keep track of users. So switching to the distributed channels can solve this issue. Next one is not utilizing the security measures properly. Instant alert system should be there, but typical identity management lacks this one and there is no proper reporting or preventive measures. And also, the storage system is not immutable, so it is easy to manipulate and no user is going to save from cybercriminal. Next thing is lack of device management with an identity NPYOD, which is bring your own device. Now, every employees, they started bringing their own devices where no firewall or security is configured in those personal devices. Even if a single device is hacked, the whole network is going to get compromised. Next is same repetitive KYC or registration process. See, when we open a bank account, we have to register with your KYC. On other hand, if you're going to do the same thing for insurance or while taking loans, etc., again, we need to register. Thus, same KYC protocols, it open up multiple access point for our info. Next thing is identity risk from online platforms. When we shop online or when we register for any service, we need to share our info. Most of these are centralized and security is not up to mark. Weak authentication protocols. The single factor authentication process, no one can fully, totally give security for identity. So companies should have two-factor authentication process. Now hackers, they breach the two-factor authentication process as well. To avoid this, the enterprise needs to have a strong multi-factor authentication process. Only centralized server gives identities. Yeah, and traditional method, only centralized servers can issue identities. Most of them are country specific and they has a total control of who they are asking the identity. As a result, many citizens were left without identities. More than 1.1 billion people in the world, they don't have identification attribute. Mishandling information. So few apps, they are mishandling their personal information. Strict protocols and security measures to limit other company. Security measures should be there. So coming to the theft or hack. So ID theft is now haunting the digital space. In 1997, a woman named Barry Nessel, she hired people. She's saying hiring them for a job. She collects personal information along with a bank account and misused many people credit cards. Same like incident, it's still happening in 2017 too. It hacked. So this all is getting happen because we are trusting a third party to handle our information. So these are the issues in the current identity management system. So to overcome this, the best solution is to have a no centralized institute issuing or having a claim over any kind of identity. So with this decentralized ones, added level of security comes. No third party or any other institute can misuse a digital identity anymore. So when looking for a great solution for a decentralized, when looking for such a decentralized identity, blockchain technology appears to be a great solution. As blockchain technology is going to be the, as it offers a decentralized solution, the value of blockchain for business, it will exceed $3.1 trillion by 2030 as a forecast. And also this graph, it depicts the global spending on blockchain solutions in recent year, and it projected through 2022. And this companies and enterprises, they started adopting the blockchain technology. Now let us learn what exactly a blockchain is. So it is going to be a distributed one as we discussed before. So it is a distributed ledger system. It promotes decentralization, transparency, and data integrity. Multiple blocks are connected in a chain-like format, which means a block, it is a data which along with a cryptographic hash ID, but the transactional data and a timestamp. So chain, it just represents a linking structure. So multiple blocks are connected in a chain-like format. So any data that would go into the block will get never altered or deleted. It will stay there forever. And this is peer-to-peer network, which means a group of devices, a group of blocks, they are connected together to create a network. Once a network is created, we can share data. It is a distributed network where peers can exchange their data without a centralized authority. Now let us see how this blockchain technology works. So, as we discussed before, it stores all the information in a ledger system. Any kind of data exchanges is called transaction. Every single user on the network is called nodes, and they get a copy of the updated ledger. First of all, a user will request for a transaction in the network. It will be broadcasted to all the nodes in the network. These nodes, they use an algorithm to validate the information. Once the block gets validated, the block will get a spot on the chain. At the same time, the transaction will be executed as well. This diagram depicts how a blockchain technology works. So someone requests a transaction. This requested transaction is broadcast to a P2P network consisting of computers known as nodes. Now these networks validate the transaction using algorithm. Now a verified transaction, it involves a cryptocurrency or contracts, or it might be any records or other information. Once verified, the transaction is combined with the other transaction to create a new block of data for the ledger. The new block is then added to the existing blockchain in a way that is permanent as well as unalterable. As, as a result, this transaction also got completed. So, digital identity blockchain. How can a blockchain help? So, creating DID, which means decentralized identifiers. So, they can be created from blockchain addresses itself, which are unique. So, owners can itself generate them. Now, registry for all DIDs are available, which means ID information that gets stored on a immutable ledger storage. So no one can access your ID anytime and steal the information. So credential notarization, which means it is similar to putting a seal on your ID. I mean a timestamp. Moreover, an electronic seal. For example, a university would provide hash for a diploma on the platform after the student graduates. It will help the student to know when the diploma was issued along with the proof of certificate. So when he uses this certificate for job or any purpose, he can show this certificate had the hash function from the university. So in reality, it can be a great way to change how people handle the certificate from any respective university, and it also gives it also gets rid of falsifying certificate issue that companies take while hiring the employees. Next thing is consent and then access right. That is user can control. Say for example, you will have the rights to share some of your info on various platforms, but only for a certain amount of time. So you will be having your all rights. And also you're using a smart contract features, which means identity as a proof can be used here so that the data exchange happens securely as well as transparently. Let me explain the difference between regular contract and then smart contract. So regular contract is a vending machine, like you are just giving an extra pay for lawyers or hospital, just wait for their service or document. In smart contract, there is no middleman like this. The every asset that we talked get transformed into a program, and this program runs as a code. It evaluates based on the task whether this asset should be go back to the person or it go back to the owner. So it serves lot of time and also it is fair to both the parties. Now let us see some algorithm that we are using in a digital identity blockchain. One is public key cryptography, also known as asymmetric cryptography. It is a kind of encryption technique which makes use of key pair involving a private and its corresponding public key. When we are saying we will use this public key for encryption, and it can be only decrypted by relevant private key and vice versa. And you see these private keys, they are known only to the key owners, whereas public key is open to others. In a blockchain, public key cryptography is used for asset ownership and for verifying the authenticity of transaction. So hashing, it is a mathematical mechanism of generating a fixed size input value from the data. In blockchain, hashing is utilized in hashing transactions and block data. So Bitcoin system, it uses SHA-256 hashing algorithm, which was originally designed by United States National Security Agency. It is also being used for decades in many sectors and services that require solid security, such as in financial services, and thus it has proven to be secure. Coming to digital signature. Okay. So digitally signing a message means in order to verify its authenticity and ensuring the integrity of the message in peer-to-peer communication, which is achieved by public key cryptography. So signing means we are hashing the original message and encrypting with the private key. That is what a signing means. For example, Bob sends a message to Alice, as well as he will send the same message, original message, and the signed message to Alice. So Alice will apply the same hash function to the original message and decrypts the signed using the Bob's public key. And she'll check if they match, if that kids match after comparing the result. So it is tampered that it is not tampered and the message came from Bob. And she used this. Thus, the integrity and the authenticity of the message lies here. So what is stored on blockchain exactly? So no private data is stored on the blockchain ledger of your system. Even encrypted and hashed versions of private data are not stored as encrypted data on blockchain. Thereby, blockchain is mainly utilized to look up the decentralized identifiers and identity owners. So this is an ID management process. This is a current process and this is a blockchain one. So blockchain, it helps to bring the multiple parties, including the ID provider, verifier, customer on the same platform. The idea behind here is to reduce the verification time, to reduce effort, and to reduce the financial burden of the enterprise. Most of the enterprises require identity before granting them access to use the resources. Upon receiving customer ID, enterprises depends on the external ID for verification, which is time consuming as well as costly. So we will be requesting for identity and customer will get the identity issued. This identity verifier has to contact the external vendor for KYC and they have to then confirm the ID confirmation and they have to. So this is how it happens. But when coming to the blockchain, it saves time, effort, as well as the cost. To explain at a high level, so customer, he'll request for identity. So this identity is issued on the blockchain itself. Similarly, when the customer requests any services, this identity verifier will do the verification from the blockchain itself. So this is how the blockchain helps to reduce the time and the cost also. So coming to the use case, let us see how an onboarding process. When we are going to do an onboard, so we have customer, enterprise, there should be an external KYC vendor, ID provider, schools, colleges, and then private sector. So we should be having an external vendor for KYC, whereas in a blockchain-based identity management, there is no such external vendor. Let us see how this works. In a legacy onboarding process, the customer will raise a request for onboarding in enterprise. Enterprise raises background verification only to the external KYC vendor. Either it might be for education with school or colleges, identity with government identity provider, employment with private sector. After verification, external KYC vendor share the status with enterprise. Based on the verification status, enterprise onboard the customers in their systems. When talking about the same in a blockchain-based onboarding process, those who all will be involved, like enterprise, school, government identity provider, or a private sector, everyone will join this blockchain network. So schools and colleges, they'll give the educational certificates which gets stored in blockchain-based users wallet. Similarly, government identity provider, they issue identity certificates again stored in blockchain-based users wallet. Employment certificate, private sector, they issues employment certificate again which gets stored in the same blockchain-based wallet. Now, the customer again raise a request for onboarding in enterprise. Enterprise, they raise a request to share the required certificate. Customer shares the required document with a specific enterprise for the given duration. And then certificate verification. Enterprise, they performs the certificate verification from the blockchain network itself and they directly onboard customers in their system. So coming to the limitations and benefits. So what are the limitations we do have on this legacy onboarding processes? It is very expensive. that is possible for duplicate KYC cost for the same customer which was verified by one reputed organization. And also, there is a lack of direct communication between enterprises and various departments of the verification process. So it is time consuming and there is a lack of transparency as well as lack of trust also. And also, customers, they don't have control on how this information was shared with other departments or units. They don't even have the control to revoke the permission to access their identities detail if required. But when coming to the benefits of blockchain, bringing the certificate issuer as well as verifier on the same platform, it helps to remove the external party from the process, which helps to save the huge cost of verification. Onboarding acceleration. By segregating the external KYC vendors from the onboarding process and bringing the identity issuer and verifier on the same platform, we are able to onboard the customers quicker on the system. And also, as this is distributed and decentralized data ledger, it helps to bring trust and the transparency, and customer-centric control is there because customer can decide with whom he or she wants to share information. What would be the duration for which he or she wants to share information, and also has the ability to revoke the permission to user information. Next, let us go through the related projects that uses blockchain for identity management. One such as a Hyperledger that starts in 2015. It is an initiative by the Linux Foundation that aims to create common open source blockchain frameworks and tools that anyone can use freely. The subpart is Hyperledger Fabric and Hyperledger Indy. So Fabric, it is a blockchain foundation for creating private permission blockchain applications with a modular design. So identities are essential here. Apart from asset ownership, resource, and access permission management are also determined by the actors' identities. Another special feature of the fabric is it allows the private channels that can be used for permission private data sharing. So Hyperledger Indy is a public permission distributed ledger project. It supports data minimization and enables identity owners to store their identity-based records. Applications don't need to store individuals' personal data. Instead, they store a link to the identity. So again, in same 2015 itself, there is two projects, Sovereign and Showcard. So Sovereign, a live distributed ledger built for decentralized identity that uses Hyperledger in this code base. It is again a public blockchain since it is designed to provide a self-sovereign digital identity for all. Identity details are stored in a digital file called Showcard in Showcard, which is owned by the identity owner, and they are usually stored on the owner's public mobile device. So identity owners have a public-private key pair for controlling their identity. Showcard system architecture consists of a blockchain layer, which includes multiple public and private blockchain networks built on the top of the blockchain layer. And the latest one is SecureKey 2019, that is on 2019. So SecureKey and Canada's major financial institution launched a blockchain-based network, Verify.me in Canada. It enables privacy with triple blind identity sharing, in which the data provider never knows the service a customer is accessing, and also the data requester does not have to know the exact credential provider other than knowing the business type of the credential provider. So these are the related projects that is in use, and also there are many upcoming projects related to this. Just to conclude, the blockchain based digital identity management, it helps enterprises as well as customers in following perspective. It gives security, data control, identity traceability, trust and transparency, accelerated onboarding, to eliminate fraud, cost effective, and also it provides single identity. Thus, we have a much scope in applying a blockchain for digital identity management. So these are the references that we have used for completing this presentation. Thank you, everyone.